Hey, I'm Nathan, and I'm doing my Sci Pop on the first picture of a black hole that was taken earlier this year. And the first thing that came to my mind was how do you take a picture of a black hole? Like the whole point of a black hole is that its gravitational pull is so strong that once you get close enough to it, nothing escapes, not even light. So, how do you take a picture of something that doesn't give off or reflect light at all? And it turns out that what you see surrounding the black hole in that picture is not actually the black hole. It's something that the black hole is currently sucking into the black hole. And what you're seeing is a large, celestial object, could be a star, large asteroid, who knows, getting spaghettified. And yes, that's actually the technical term for it. You can look it up. And when something gets spaghettified, the black hole is basically accelerating it so great that it's like squishing all of the matter and stretching all of the matter into this very thin line of atoms and matter and stuff. And when that happens, there are really forceful collisions happening between all of those atoms that were in that celestial object. And all those collisions are exchanging energy between all of those different atoms and a lot of energy very quickly. And that is actually when those atoms release the light that you see in that picture. And why those atoms release light has to do with uh, quantum theory and the Bohr model. So, you have the atom, which has the nucleus in the middle, and then you have all of those electrons surrounding it, which are in those clouds that we call orbitals. And so there are multiple energy levels for every orbital. So you've got the 1s, which is smaller, and then you've got 2s, which is bigger, and so on with all the p, f, and all those orbitals. So, sorry, panicking words. So the those electrons are usually found in their ground state, which is the lowest orbital that they can go into. There can only be 2 electrons per orbital, and so you fill them all up, and then on the outside, it's the lowest energy level that it can be in. But when an electron gains energy, it can actually pop out of that energy level that it is currently in and raise into a higher energy level when it absorbs that energy. And the problem with that is now that electron is very unstable up there, and so it drops back down to its original or ground state place or energy level. And to do that, it needs to release its energy. And it does that in the form of light. So that is what's happening when that object is getting pulled into the black hole. It's getting spaghettified. All of those collisions are happening. Energy is going between all of these atoms, and electrons are getting excited, and they pop out into a higher energy level, but they're unstable, so then they fall back into their stable positions or their ground state, and at that moment they release light. And however much energy they must release to return to their ground state determines the frequency of light that is emitted. So the more energy levels you jump down, the more energy you have to release So the more energy levels you go down, the higher frequency of light you release. And yeah, that is the chemistry behind the first picture of a black hole.